Click the bell icon to get latest videos from Ekeeda.
Hello friends, today we are going to discuss about a thread library known as pthread, how it is implemented including an example of C program, and then what are the advantages of using the pthread and how actually pthread can be performed in different operating system. Pthread is a POSIX standard for defining an API which will define to create and management of thread. Now, this is a specification of thread behavior, not an implementation. This specification can be implemented by the operating system designer in any way they wish. Now, this implementation basically depends on application and different types of machine, including the multi-core processor, single processor, and multiprocessor environment. Now, all the Unix-based systems, including the Linux, Mac OS X, and Solaris, use this pthread. Windows directly not use the pthreads natively, but there is a third-party implementation of pthread available for Windows. In a pthread program, a pthread creates different threads or several threads to begin execution at the latest stage. At first, there is a single thread which begins execution within a main, and after the execution of the main and setting up initializing the parameters, the main thread creates a second or the child thread to perform any other actions. Each thread has a set of attributes including the stack size and the scheduling operations. Now these attributes can be set by a different and particular function. Because we use only the default attributes and the attributes that are special to a program must be set within a PTT and ATT or ATT function. This attribute specified function can set then the special type of attributes for each program. A separate thread can be created using a pthread create function. So along with the thread ID that we have created with the PID statement, along with the thread ID and the name of the function that is used to create and begin the execution of the separate thread, the attributes, and at last the parameter that is an integer or any other parameters received by the command line is passed to this pthread create function. So it will create the separate thread to execute the particular function. After creating the child thread, the parent thread has to wait for the termination of the child thread by using the pthread join function. This pthread join function can then wait for the parent statement or parent thread to wait for the child process. Now the child thread can terminate by calling the pthread close termination function. This pthread termination can be done with the pthread exit function. Now when the parent gets the return of the child thread, then it can output the value of the shared data which the both of the threads were shared. Now we will solve an example with the help of a C program to actually create and give a POSIX pthread API for creating a multi-threaded program which will perform the summation of non-negative integer numbers that is received by the command line argument and is done in a separate thread. First, we include the pthread.h header file to take advantage of the POSIX API of pthread. Now we are declaring a variable sum here which is a global data and which should be shared among the main thread and the child thread as we have described earlier. Now we are giving the prototype of the function that the thread will call to begin the execution of the separate thread where the actual summation program will happen. Now we are declaring two variables. First is the pthread t, which is help to defining the tid or thread id to the function to be passed with the parameter, and the next one is the set of attributes of the thread that is also be passed to the parameters as of the pthread create function. Now this part is assigning and helping with the argument from command line for the taking non-negative integer. First we are seeing that if the argument is not specified in integer, and the second one is using the a to y function, which is helps to convert the character to integer, and if it is less than 0 means that if it is a negative number then we are displaying an error message, then it should be an integer, positive integer number. Now this function pthread_attr_init function is actually used to get the default values of the set of attributes of that particular thread. Now next we will create the thread. Here we are using the pthread_create function to actually create the thread. This pthread_create is having four parameters. The first one is the thread ID, the second one is the set of attributes, the third one is the function that is actually calling the next thread or the child thread to begin the execution. Its name here is runner. And the last one is the command line argument of the non-negative integer that we are getting from the input. As we have created the separate thread, now the parent thread is waiting for the child thread to complete its termination by using the pthread_join function. With pthread_join function, we are getting the thread ID and specifying the null as the default parameters of this function. Now at last, when the child thread returns, actually it is returning the output and we are displaying the sum of the non-negative integers that is performed in the runner function. Now we will see that what is happening inside the runner function. So here in the runner function, which is passed with a parameter called param, which is actually the integer value, non-negative integer value, that's the sum to be needed to calculate. Now we are using the normal C program to calculate the sum of the non-negative integers, that is from I is equal to 1 to the non-negative integer value, and we are returning the integer value sum as the sum is a global shared data. Now after performing the sum function, we are using the pthread exit function to actually returning from the child thread to the parent thread. Here the child thread is terminating successfully, that is why exit is having the parameter 0. So now in this way the child is returning the parent thread and outputting the value of the shared global data sum. Here we are creating a single separate thread in this program. Now there can be options and operations that can be used by a multi-threaded environment to make more than separate one threads to be created. Now we can put the normal pthread join function where the parent thread can wait for a single thread of child to execute and terminate. Here we can put the pthread join. It's simply inside a for loop and make the for loop run for multiple several times to wait for the multiple several separate child threads to terminate their execution. In this way, pthread specification can be implemented in many Linux and Windows-based operating systems. Thank you for watching this video. Stay tuned with Ekeeda and subscribe to Ekeeda.